In this video, we're going to explain how to design a JK flip-flop given a D flip-flop. So we already have a D flip-flop and we want to design a little circuit here that will take two inputs, J and K, and determines the value of D that will make this entire circuit act as a JK flip-flop. So let's remind ourselves of the characteristic table of the JK flip-flop. So here we have 4 columns. First 2 columns are the inputs of the JK flip-flop, J and K. The third column is Q, the current value of Q. The last column is the new value of Q, or Q next. We know that for the JK flip-flop, Q next is Q, or remains the same if J and K are both 0. If J is 0 and K is 1, then the output is reset to 0. If J is 1, K is 0, then the output is set to 1. If both J and K are 1s, then the output will toggle, meaning if Q is 0, Q next is going to be 1, and the opposite is true. To start solving the problem, we're going to add an additional column here and label it D. We know from the characteristic table or equation of a D flip-flop that D is actually equal to Q next. So we can record the values of Q next as the values of D. I'm going to say 0, 1, 0, 0, 2 1s, and then 1, 0. Now I have a complete table. From the table I can create a K-map. I will need a 2x4 K-map whose variables are J, K, and Q. So this is actually J. It's not really clear. Okay. I'm gonna fill in the table with the values of D. I'm gonna have 0, 1, 0, and then 0. In the second row I will have 1, 1, and remember to skip 1 or to swap the last 2, so it will be 1 and then 0. Let me complete the K-map with the values. First column is 0, 0, K is 0, Q is 0. Second column is 0, 1. Here I have 1, 1, and finally 1, 0. For the rows, first row is 0. The second row has a value of 1. Next step I'm going to do is group the ones in my K-map. I will have 2 groups, these 2 ones together, and I can group this one with the one on the other corner. Now what I can say about D is that D is equal to, from the first group, this one, I can say that D is equal to not K actually, K bar, ANDed with Q. For the second group, I'll have J being 1, so J, ANDed with not Q, because that's the constant and it has a value of 0 among this group. So AND J, Q. Now I have a complete expression for D, and that is all I need from this manual solution. I can now move to Logisim to simulate the circuit. So let's start Logisim, and then to help me with the expression, instead of going back and forth between my notes, I'm gonna write D is equal to K not, or not K, Q ORed with J and Q. Okay. Now I will start placing components. I will need 2 input pins to test my JK flip-flop or my design. First input is going to be J, the second input will be K. I'll need 2 input ANDs, so I'll place 1, change it to 2 inputs, and even maybe make it smaller by changing the gate size to narrow. I'll take a copy of this one because I will need it later, and I will also place a 2 input OR gate as such. Change the number of inputs to 2. Make it narrow so it will save some space here for the other components. I will also need one inverter for k. Let me go back to the expression. Here for the second, I just noticed that for the second group, I have j and I said not q, but I recorded q. So let me add the bar here. So that is the final expression I need. Okay, so let me also fix it in the note here. I will need j ended with not q. Okay. So I will need only one inverter to invert k. I don't need to invert q because I already have it inverted as in the second output of the D flip-flop. So the input to the D flip-flop is going to be the output of this OR gate. Okay. This OR gate takes two inputs. One is the output of this AND gate, the other one is the second gate's output. Okay. I will need to invert k, so I'm going to connect the inverter to k. Okay. K is going to be the input to this gate along with Q. So I will take a wire from Q and connect it here. I'm done with this AND gate, with this OR gate. I'm left with the last AND gate. This one takes J as its input along with Q bar. So I'm going to connect J and Q bar is here. I'll go around and maybe just to avoid any shorts, I'm going to stop here and then go around and connect it this way. Now I have almost the complete circuit. All I need to connect next is the clock. I'll connect it here, and I will also connect an output pin at Q just to help me read its value. Just make sure that simulation is enabled and that also text is enabled. You can make the frequency of the text smaller, so you'll have enough time to observe the value of the output. Before I test it, I'm going to label my output as Q, and now I will test the different possible combinations. I know that when J is 0, K is 0 also, the output will remain unchanged. It will stay the same. When J is 1, K is 0, the output will set to 1 at the next clock edge and at the next rising edge, and it will remain the same. While J and K are both 1, the output will toggle at every cycle. So at the next rising edge, the output will also toggle again continuously. The next test I'm going to do is when J is 0, K is 1, I know the output should reset to 0 at the next rising edge. The last test I'm going to do is when the output is 1 and it will remain unchanged. So I'll change J to 0 now, and I will notice that the output will remain constantly 1 as long as both J and K are 0. Okay, this completes the testing of our design, and we can tell that it's working as expected.